All right, today for day 8 in Unit 9, we're going to be looking at special segments in circles still, okay? And instead of looking at the angles created by those segments, today we're going to look at the length of the pieces of those segments, okay? So when I look at the first ones, I have chords. For these first two, I have chords that are intersecting inside a circle. So if we have two chords that intersect in a circle, the products of the lengths of the chord segments are equal. Okay, so the products, what does product mean? You've got some difference, product, and quotient. What does product mean? Multiplication. It's the result when you multiply. Okay, so the result when we multiply the lengths of the chord segments, they're equal. So if I look at this blue chord, the one I'm going to, it's a dark blue, but if I look at this one that I'm darkening in, the two segments that are the mini segments that are created by the whole segment when it's intersected are going to be A and B. So if I take that product, and then if I look at the other chord that I'm going to highlight in orange, the segments that it's created into have a length of C and D. So if I take the product, if I multiply A times B, that's going to give me the exact same length as C times D. So when I look at my first example here, I can see that I'm going to say 6 times X is going to equal 3 times 8. So 6 times X, that's just 6X. And 3 times 8 is 24. So how big is X? 4, right? Because we're going to do division property of equality on both sides, and I divide by 6 and I get 4. Sometimes we have to be kind of careful with it, because when I look at this one on the right, I can see that this side to side is going to be X times X equals, and then this piece here is easy. That's going to be 2. But how long is this piece? 10, because of that point there in the middle, that 10 is not to the whole thing, right? Whenever you have a number that's just in a picture and it doesn't specify where it goes to, it's going to go from point to the next point. So that 10 is just from here to here, which means that 10 is a radius. So that means the rest of that diameter on the other side of it is also 10, but 2 of them are up here, so how long is this piece here? 8. So how long, we just practiced segment addition in our warm-up, how long is that whole second piece of that segment? 18, right? It's going to be 10 plus 8, so this whole, I've got 2 and 18. Does that make sense? Does everybody see where I got the 18 from? Do I need to go over that again? Okay, so to find the 8, I use the idea of the radius. And then you just add the 8 and the 10 together to find that second piece of the chord that's being intersected by the chord that's X and X. X times X is X squared equals 2 times 18 is 36. How do you unsquare a square? Square root. So X equals, the square root of 36 is 6. So that's when I have chords intersecting inside a circle. When we have segments that extend, so either tangents or secants, and they intersect outside a circle, there's going to be a formula you're going to be given. Excuse me. Okay? The formula, when you first see it, is not going to make any sense at all. And then when you apply it a couple times, you're going to say, okay, I get it. Okay? It is the external segment times the whole segment equals the external segment times the whole segment. And that looks like a weird way to solve something because, of course, something on the left-hand side that equals the exact same thing, well, of course, it's going to equal because they're all going to be the same numbers. But they're not. Because when I say the external segment and the whole segment over here on the left and then over here on the right, we're going to be looking at different segments. So these are different external segments. These are different whole segments. Okay, so let's see how I apply this. Okay, if I'm looking here at two secants, when I look at this top secant, AC, my external is this piece here that's outside. So that's going to be AB. The whole thing is going to be AC. That's going to be equal to, then we're going to look at the other segment. My external piece is AD. Oops, I'm writing AD. And then the whole thing is AE. So external is the little piece that's outside, right? So it's the external of one segment times the whole of that same segment equals the external of a different segment times the whole of the other segment, okay? If you have a secant and a tangent, so this is two secants, so it's real clear there's an external, there's a whole, and they're different things. When I have a secant and a tangent, the secant part is real easy, but let's talk about the tangent. When I look at this tangent, my external is AB. The whole thing is also AB. That's going to be equal to the external AC, external, AC, and the whole thing AD. Whole. Which this one, when you have a secant and tangent, you could rewrite it as the tangent squared equals the external times the whole. But rather than having to memorize, like a lot of times they'll teach this as two separate formulas, external times whole, tangent squared equals external times whole. But for me, it's easier to just remember the one formula, and I just know when I apply this when the external is the whole, right? Rather than trying to remember two different formulas. Okay? All right, so let's try this. A bunch of examples. All right, so on my first one, I have my external is 3.3. The whole is also 3.3, so I can actually just do 3.3 times 3.3 or 3.3 squared. It's going to be equal to my external is 2.2. What's the whole thing? How do I write that whole thing? 2.2x? That's wrong.
2.2 plus x.
2.2 plus x. We just did a whole warm-up on segment addition so that you could figure that out right there. That's the whole reason we did the warm-up. Was so we would remember it's not 2.2 times x. It's I have to walk 2.2 plus I have to walk x. 2.2 plus x. Okay? All right, so now let's solve this. Put a calculator around here. There we go. All right, 3.3 squared is 10.89. equals, on my right-hand side, I'm going to go ahead and distribute. 2.2 times 2.2, or 2.2 squared, is 4.84 plus 2.2x. What's the first thing I'm going to do? Subtract 4.84. 10.89 minus 4.84 is 6.05 equals 2.2x, and then what? Divide by 2.2. Division property of equality. $2.75. Okay. The next one, external times whole equals external times whole. What is the external of the top segment? 8. What's the whole of the top segment? 16, because of the tick marks, right? They're both 8, so 16 equals, what's the exterior of the bottom? 6 times what's the whole? 6 plus 2x, or 2x plus 6. It doesn't matter what order you put it in. All right, 8 times 16 is 128 equals, distribute 6 times 6 and 6 times 2x, 12x. Then what? Subtract 36, and I'm going to get 92 equals, I subtracted that 36, so equals 12x. And then divide by 12, and I'm going to get 23/3. It says to round to the nearest tenth in the direction, so if I do that, I get 7.7, because tenths is 1 decimal place. I would still take the fraction if you left it as 23/3. It's actually more accurate, right? All right. So now we're just going to go over everything we just did a few times. Number 1, find x. So remember, the little pieces of the chords, the products of them are equal. So the first one, I'm going to have 6 times 5 equals 2x times 3x. 6 times 5 is 30. 2x times 3x is 6x squared. What am I going to do first? Divide by 6, and I end up with 5 equals x squared. Then what? Square root. Which, if you want to give me an exact answer, then we would say x equals the square root of 5. If we want to round that to 3 places, the square root of 5 is 2.236. So approximately 2.236. Okay. Do we want to start with the segment with the x or the segment with the 2 and the 7? The 2 and the 7. So one little piece is 2 times how long is the other piece? This is, I need the whole length. 12, right? Because this little piece here will be 5, so that it matches with the 7 for the radius. So then the whole other piece of this chord, I've got 2 and 12. so that my diameter is 14. Equals, I can see this one's x. How long is the other one? X. And they didn't tell me it's x, but using the properties from before, I know that if I leave the center, if I'm a diameter or a radius and I'm perpendicular to a chord, I know I bisect the chord. So these two have to both be x. 12 times 2 is 24. X times x is x squared. So we're going to square root. So you can either simplify the square root and say, okay, 4 goes into that, so that's going to be 2 square roots of 6. Or you can just give me the rounded square root of 24. 4.899. Questions on 2? Yes.
How did we get the 5?
So the diameter here is 7, right? So that means, or sorry, the radius here is 7. That means this radius here is also 7. And if I've got 2 on the outside, then left here there has to be 5. So that whole piece is 7. And there's a little bit of 12. All right, number 3. External times whole equals external times whole. So if I look at this one, what's the external? 13. What's the whole? 13. Equals, then on the other one, what's the external? 9. What's the whole? 9 plus 5x. So when I multiply, I'm going to square the 13, and I'm going to distribute the 9. All right, what am I going to do first? Minus 81. When I take 81 away, I get 88. I take that one away, so I just have 45x. Then I'm going to divide by 45, which it doesn't divide, so you can either say it is 88 over 45, if you want an exact answer. A rounded answer would be 1.956. Questions on 3? Okay. Number 4, let's do the top one and then the bottom one. On the top one, what's the external? 6. What's the whole? 6 plus 4x. Equals, on the bottom, what's my external? 6. What's the whole? 6 plus x plus 3. On the left-hand side, I can distribute that 6. 6 times 6 is 36. 6 times 4 is 24. On the right-hand side, before I do that, I'm going to combine these like terms and say that's really x plus 9. And then I'm going to distribute my 6. You don't have to do that, but at some point you're going to combine them anyways. And it's easier for me to combine them when they're smaller numbers. So then I'm going to have 6x plus 54. Okay? What do we want to do first? Subtract 6x. Cancels out on the right side. 36 plus 18x equals 54. Okay, then what? Subtract 36. 18x equals 54 minus 36 is 18. Then what? Divide by 18. And how big is x? 1. Okay. Questions on 4? Okay. Let's look at 5. External times whole equals external times whole. I'm trying to rotate my page so I have a little more space. Just a hair more. Okay. External times whole equals external times whole. If I start with the top one, and you don't have to, that's just what I do. My external is, and the whole is, and then for my other segment, my external is, and the whole is x plus 5. Alright, so I end up with 36 equals x squared plus 5x. Guess what this means? It's my favorite F word, not your favorite F word.
Oh.
My favorite F word. We're going to have to factor. I said my favorite F word. Not yours, mine. Factoring is fun. In order to factor, this has to be set equal to 0. So I'm going to subtract the 36 to the other side. So that I can have 0 equals x squared plus 5x minus 36. Then we can use our x method. On this one, I don't know that the x method is the easiest way to go because since there's not a number in front of the x, it becomes a little bit easier. But we can look at it in case you forgot it and want to use it elsewhere. When you're doing the x method, if you have a 1 in front of the x, whatever's in front of the x squared just becomes your denominator there. And then we're looking for things that multiply to a negative 36 and then add to a positive 5. Which really means since they have to multiply to a negative 36, they're really going to subtract to a positive 5 because one has to be positive, the other has to be negative. So my multiples of 36 are going to be 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. I'm really going to be subtracting because I want a negative 36, so one has to be positive, one has to be negative, right? Which two am I going to be using if I want to subtract them and get a positive 5? The 9 and the 4. If I want a positive 5, which one of these is negative? The 4, right? Now, if I had a number underneath here, if there wasn't a 1 in front of here, if I had a number underneath, then I would want to reduce that fraction, right? But since it's 9 over 1 and negative 4 over 1, we just leave it the way it is. So this is going to factor into the denominator 1x, then the numerator plus the numerator, plus 9. The denominator 1x plus the top, which is a negative 4, so really it's minus 4. And then when we're factoring, we say, okay, if these two are multiplied together and they equal 0, that means one or both of them have to equal 0. So x plus 9 must equal 0, and x minus 4 must equal 0. Subtract 9, x equals negative 9. Add 4, x equals positive 4. In algebra, we get to stop there and say, there's two solutions, yay. In geometry, we can't. We have to look and say, do the solutions work, right? Can x be a negative 9? Can you have a negative segment length? No. So because you can't have negative segments, negative 9 is not a solution. But can x be 4? Yeah, absolutely. So 4 is my answer. Okay, number 6. External times whole equals external times whole. So my external on the top segment is 12. The whole thing is 27. Equals the external is x plus 8 times the whole is x plus 8. So the left hand side, 12 times 27, oops, my calculator turned off, is 324. On the right-hand side, we have to double distribute, right? We have to distribute the x, and then we have to distribute the 8. So x times x is x squared. X times 8 is plus 8x. And then we distribute the 8. 8 times x is plus 8x. 8 times 8 is plus 64. I'm going to combine the like terms, the 8x plus 8x. So 324 equals x squared plus 16x plus 64. Again, because I have an x squared and I have an x, I'm going to have to do Miss Bishop's favorite F word and factor. But in order to factor, I need this to be equal to 0, so what do I have to do first? Subtract the 324. So I'm going to end up subtracting the 324, which is going to subtract it from the 64. So x squared, well, equals 0. X squared plus 16x equal, or minus 260. Okay, so now I get to factor this, so we can use our x method. Since I have a 1, it makes it nice and simple. I need to multiply to a negative 260, and I need to add, but really subtract, to a positive 16. So if you want, here's a little trick since you have access to a calculator in this class. If you open up a graphs page and you want to know what are all the multiples of 260 or of whatever number, you can take that number divided by x. When you graph it, if it's a big number, it's not going to show up on your screen, but that's okay because we don't really care what the graph looks like. But if I look at the table, it'll all of a sudden show me that 1 times 260, 2 times 130, right? 3 obviously doesn't go in evenly, okay? So it'll show me all of them, and I'm just looking for the pair that's going to subtract to 16. So stop me if you see a pair that subtracts to 316. Or sorry, to 16. Oh wait, look right here. 10 and 26, right? 10 and 26. If I wanted to add to a positive 16, which one has to be negative? 10. So that negative 10 times negative 20, or times positive 26 gives me my negative 260. And my negative 10 plus 26 gives me my positive 16. All right, so 0 equals 1x minus 10, 1x plus 26. So that means x minus 10 equals 0, and or x plus 26 equals 0. Add 10 to both sides. X equals 10. Subtract 26 from both sides. X equals negative 26. Will 10 work? Can this segment be 10 plus 8? Can this segment be 18? Yes. So this one works. That's a solution. X equals negative 26. If I put a negative 26 plus 8, will that work for this segment? No, because I'll get a negative answer. So that doesn't work. Okay? Questions? One more? All right, number 7. I left a lot of space for that factoring on number 6. All right, number 7. Do you want to do the secant first or the tangent first? Secant. Okay. So my external is x minus 3. The whole thing is x minus 3 plus 16. Equals, on this one I've got, my external is x plus 3, and the whole thing is also x plus 3, so you could just write it as x plus 3 squared, right? Oops. You could just do it as x plus 3 squared. Because the external and the whole are both the exact same thing. Okay? All right, I'm going to first start by combining my like terms in this second little piece. I'm going to have x minus 3, x plus 13 equals, I am going to go ahead and write this out because it might be easier to try to double distribute. If you don't want to double distribute, if you remember the box method, you can do the box method. Does anybody want to see the box method in case you forgot it? We're all okay with double distributing? Okay. So for my double distributing, x times x, x times 13, good. Then my negative 3. Negative 3 times x is?
Negative 3x.
And then negative 3 times 13, negative 39. And then on the other side, I'm going to double distribute that other side as well. So x times x is x squared. X times 3 is 3x. Then I do the same thing with the 3. 3 times x is 3x. And 3 times 3 is 9. It's important to not try to square this x plus 3 squared without rewriting it, because then a real common mistake is to just say, oh, that's just x squared plus 9. But then you're going to miss these two little 3x's in here, right? If you don't write it as two separate binomials being multiplied together. Okay? All right, let's combine our x's on the left side and then our x's on the right side. So x squared plus 10x minus 39 equals x squared plus 6x plus 9. So since I have x squareds and x's, it looks like I get to do my favorite F word and factor. But in order to do that, that means it has to be set equal to 0. So that means I need to either move everything from the left over to the right, or everything from the right over to the left. Do we want to end up with our 0 on the left or the right? Doesn't matter. Nobody has preference? Okay, move everything to the left. So I'm going to start with this x squared. I'm going to move this x squared by subtracting it. When I do that, look what's going to happen. This is actually really great for those of us who don't like Miss Bishop's favorite F word. Because what's going to happen on both sides with my x squareds? They're going to cancel out. And we're no longer going to get to factor. Because now it's just 10x minus 39 equals 6x minus 9. And I no longer have any squares. Now I just solve this like a regular 3-step Algebra 1 problem.
Isn't it plus 9?
It is plus 9, thank you. All right, what should I do first? Okay, add 39 to both sides. When I do that, 10x equals 6x plus 48. Okay, then what? Subtract 6x. (4x) equals 48. And then divide by 4. And x equals 12. Okay. Any questions on any of these? All right. If I scroll out, I used a lot of pencil today. Normally I use a lot more color. But I just kind of wanted to be able to show you at the end. Everything that I did in pencil was algebra. And the only things today that were geometry were what I did in pen. So just the setup of each equation was the only geometry we did today, right? Pretty much everything we did today relied on our algebra skills.